Okay, for number 3C, this one's going to be even a little bit simpler. We have cosine of pi x over 2. There's no derivatives or integrals to be taken here because we know the series form of cosine already. This one is just an exercise in making sure you write out your series correctly, because pi x over 2 is going to give you a lot of things to powers in your series formula. So remember that cosine x in series format. So what cosine is it's alternating, starting with positives. It has even powers of x and those corresponding even factorials on the denominators. So what we have here is when we're taking pi x over 2 and plugging it in everywhere there's an x, it's going to change our series as well as change our interval. So what we have now is our sum n equals 0 to infinity. Everywhere there's an x, we're going to plug in pi x over 2. Keep in mind, our interval here is negative infinity to infinity. Thus, you should expect that when we have to try our interval change, it's actually not going to do anything because we had a negative infinity to infinity, but we'll see about that. So we keep our regular series, but instead of x, we're going to write pi x over 2. over 2 in factorial. So here we have that x is any real number from negative infinity to infinity. This says here then that pi x over 2 has to be any real number. But you can see if you solve this for x by multiplying by 2 dividing by pi, that doesn't change anything. So our interval of convergence here is still all real numbers. So the last thing we need to do is, if you were given this problem on an exam, this is probably not how it would be written. How it would be written is with all the terms of this fraction separated and raised to their own powers. So you want to get in the habit of doing that. So we would have pi to the 2n, x to the 2n, and we would have a 2. Now this 2 would be on the denominator. 2 to the 2n, 2n factorial. This is most likely how you would see that written. So when you have, a fraction or a product of things that are all raised to a power, typically when you write them in the series notation, you want to separate all of those terms. So this one didn't require anything extra in terms of derivative and integral, just plugging in for x. Even though this seems like kind of a trivial result, remember that you do have to do this in general for most functions. Just so happens for this one, it worked out to not change the interval of convergence.